The question says that a parallel plate capacitor in figure 8.6 made of circular plates, each of radius 6 cm, has a capacitance C is equals to 100 picofarad. The capacitor is connected to a 230 volt AC supply with an angular frequency of 300 radians per second. Now we have to calculate what is the RMS value of the conduction current, and is the conduction current equal to the displacement current. And in third question we have to determine the amplitude of B at the point 3 cm from the axis between the plates. Now we know that capacitance is a relationship between the charge and the potential difference across the capacitor, and it is given by C equals to Q by V, where Q is the charge and V is the potential difference. And the conduction current for AC voltages, the RMS conduction current is equal to IC equals to omega C by omega C V RMS. Here it comes from V RMS divided by the impedance XC, and we know that XC is for the capacitor is 1 by omega C. So we will get the conduction current as omega C V RMS, and the peak current is related to the RMS current as I peak equals to root 2 I RMS, and magnetic field at a distance r from the axis between the plate is mu naught I peak r by 2 pi r square, where r is the distance of the point from the axis of the plate, and this capital R is the radius of each circular plate. Let's calculate the conduction current. We have been given the capacitance, that is 100 picofarad, and VRMS is 230 volt, and omega, the angular frequency is 300 radians per second. So RMS current would be equal to IC omega C VRMS. Now substituting in this formula, we will get a value of 6.9 microampere. So the conduction current is going to be equal to 6.9 microampere. Now let's calculate the displacement current. So displacement current arises due to the changing electric field in the capacitor, and Maxwell's equation predict conduction current equals to displacement current. Now since the capacitor is connected to an AC source, the time varying electric field ensures IC equals to ID. So yes, IC is equal to ID here. The conduction current equals the displacement current. Now calculation for the peak magnetic field. Now for calculating the magnetic field amplitude, we will use the peak current. So we will use this formula, mu naught I peak r by 2 pi r square. So substituting the values in this formula, we will get a value of 1.63 into 10 to the power minus 11 Tesla. Thank you.